Hello, everyone. Happy Tuesday. This is Hoot number 70, I think, 70. And today I'll be going through the Istio multi-cluster documentation. So I'll try to look at the docs with like fresh eyes. And I've done this before. I've set up Istio multi-cluster, but I'll try to like magically forget all of that. And try to go through it again and see if there's anything that could be improved in the documentation, could be maybe explained better or differently, or if there's anything missing, or if there are things that are not clear. So I think it's going to be interesting. If you've done Istio multi-cluster, if you've tried to set it up before, let me know in the comments. Feel free to ask questions. I'll try to answer them as I go through the documentation. If I don't know the answer, we'll figure it out somehow. Also, if you've set up multi-cluster before, if you have any tips and or tricks or anything that you want to share, let me know and I'll share a link. And if you're willing to come live with me and talk about it briefly, we can do that as well. If not, feel free to like post a comment, let me know. And yeah, let's get started. Let's start sharing. I've already prepared, well, set up my repo, pulled down the repo. Oh, let me actually add this here. I'll make the fonts bigger because I think it's not very clear. So what I have on the right side, and I'll make that smaller for now. I've cloned the Istio.io repo. That's where the documentation is. However, if you're like sometimes if you're doing like if you're looking through the docs and you're trying to make a fix in the documentation, or actually stuff that shows up on the website, sometimes it's not in Istio.io repo. In some cases, it's in the API repo, especially if you're looking at any of the like references pages. All those are created automatically from protofiles. So let's say you're going through this and you find a typo, or you want to fix something here, change something here, you would go to the Istio API repo. So let me share that one there. So this repo, right? So this is one, and the other one is Istio.io. I've already forked it, but so let me share both of these in the comments. Because typically the documentation, fixing a typo or clarifying something is the easiest way to get started with not just Istio, but in general, any open source project, right? That's the easiest way to get your contribution, the first contribution in. All right. I've also, before I start, I've also set up, so I'll try to use, oh, look at that. I've tried to use, I guess I'll have to use kind because I didn't increase my quota on my account. But I wanted to use kind. I wanted to use the actual clusters, but we'll try to set it up with kind. And if it doesn't work, I'll do like one on GCP and one cluster on Azure. But we'll get to it. I just want to go through the docs first instead of jumping into the like hands-on installations and all that. All right, so let me just make sure that I have all my windows here so I can see all the comments. All right, well, let's get started. So installing multi-cluster. So this is the page that I'll be starting from. And this is, if you go to istio.io, under setup, install multi-cluster, right? And it's installing Istio mesh across multiple clusters, and there's multiple sub links, let's say. So let's go with the first one, which is before you begin. So what are the things you have to do before you begin a multi-cluster installation. So first off, you have to review the deployment models guide. So let's go, we're 3 links deep. So when configuring production, you'll need to answer a number of questions. So yeah, so you have to decide what is the model of, how is your deployment model going to look like, right? So you're going to have, first of all, single cluster, multiple clusters. We know we're going to have multiple clusters, right? Because that's what we're talking about. Then the next question is, are the services going to be in a single network? So across your multi-clusters, will those clusters be in the same network, or will they be in different networks? So let's say I set up AWS and GCP; those will be separate networks, right? And there's some nuance or some differences there on how to set it up, especially the communication between the 2 clusters, right? It's basically saying, will it be a single fully connected network, or will you have multiple networks where you will need gateways to connect the services, right? So the services from one cluster between the 2 clusters will use a east-west gateway. And I know some of the things, but I'll be like assuming out loud some of the things here. So you'll be using the east-west gateway to communicate between the services in different clusters. The next one is there a single control plane that's shared across clusters? Or do you have multiple control planes that are deployed to get high availability? So there's with configuration with Istio profiles, you can set up like a single control plane, or you can do, there's one of the profiles that's meant for multi-cluster setup that doesn't rely on a control plane running in that cluster, but it connects to the control plane running in a different cluster. Are all clusters going to be connected into a single multi-service mesh, or will they be federated into a multi-mesh deployment? So based on these questions, there are different choices that you can make. So single or multi-cluster, single or multiple network, single or multiple control planes, and are you going to have a single mesh or multiple meshes that are going to be federated together? So in production, you can use a mix of deployment models, right? So having more than one control plane is recommended. So you would have a control plane at each one of your clusters. But then what you could do is, right, you can combine these and say, well, I'm going to have 2 clusters with a single that share the control plane, and then the third one will have its own control plane in a different network, right? But then you can connect all of those to share both the control planes. So workload instances run in one or more clusters. You can confine clusters to availability zones and regions. Clusters are the boundaries for configuration and endpoint discovery. So each Kubernetes cluster has an API server that's going to manage the configuration for the cluster as well as serving service endpoint. I like these things. Notice the dotted or dashed underlined words. So if you click on them, you'll get these pop-ups that explain the network reachable manifestation of service, workload instances, exposed service endpoint, but not all services have service endpoints. Since Kubernetes configures this behavior on per cluster, this approach helps limit the potential problems caused by incorrect configurations. In Istio, you can configure a single service mesh to span any number of clusters, right? So the simplest way, single cluster, one mesh, single network, right? So you would go to any of the cloud providers, wherever, set up a cluster, you would get a control plane, you would install Istio, you get a control plane, you get a single mesh, and this is the simplest deployment that you can have, right? So it's very simple, but lacks features. So fault isolation and failover, right? So you can't do, like if your service A goes down, it goes down, right? There's nothing to failover to. In case of multiple clusters, you can do a failover to another cluster. So Arjun asks, which choice is easy to maintain and advantages and disadvantages? So I think this is, starting with single cluster, it's this one gives you some advantages and disadvantages, but I think in the end it all comes down to like what you need and what you want, right? I know that's probably not the answer. There's no definitive answer. I think so. There's some best practices, right, or recommendations. For example, for like high availability, we do recommend to have a control plane in each cluster, right? So you can configure a single mesh to include multiple clusters. So using a multi-cluster deployment within a single mesh uh, gives you these capabilities. So you can do fault isolation and failover, right? So one cluster goes down, you can automatically failover to the second cluster. You can do location-aware routing. So if you have clusters in different regions or different zones, different locations, you can decide to route to the instance that's uh, closer to the caller, right? Various control plane models. So this is single, right? Single control plane. So one control plane for all clusters shared, right? Or control plane in each cluster. Team or project isolation. So each team runs its own set of clusters, right? So this is the diagram. So notice the outermost rectangle is the Istio mesh. So we have a single mesh. Um, you have two networks, east and west network, and then in west you have two clusters, and then in east you have a single cluster, and all these share a control plane that's probably deployed in one of these clusters, right? But all of these share the control plane. What is the practical use case of having multi-cluster with separate networks for each Kubernetes cluster? Well, it's the one is like isolation. The other one is, let's say you're doing cross cloud provider, right? You automatically have separate networks at that point. So with multi-cluster, this is again general comments here give you a greater degree of isolation and availability. However, yes, you do increase complexity, right? Uh, if you have high availability requirements, you will need clusters across multiple zones and regions. You can canary configuration changes or new binary releases in a single cluster where the configuration changes only affects a small amount of user traffic. Additionally, if a cluster has a problem, you can temporarily route traffic to nearby clusters until you address the issue. Yes. And this is like, I reading this, let's say I magically forget everything. Reading this is like, oh yeah, this sounds excellent, but how do I actually do this? Right? Like it sounds, yeah, I can do this if cluster has a problem. It makes sense. I can just route the traffic somewhere else and fix the issue. But how do I do this? Right? I want practical example of this, right? So you can configure inter-cluster communication based on the network and the options supported by your cloud provider. For example, if two clusters reside on the same underlying network, you can enable cross-cluster communication by simply configuring firewall rules. Okay. Within a multi-cluster mesh, all services are shared by default according to the concept of the namespace sameness. So traffic management rules provides fine-grained control over behavior of multi-cluster. So namespace sameness. So within multi-cluster mesh, the sameness applies, and all namespaces with a given name are considered to be the same namespace. If multiple clusters contain a service with the same namespace name, they will be recognized as a single combined service. By default, traffic is load balanced across all clusters in the mesh for a given service. So cluster 1, cluster 2, you have namespace book info in both of them, and you have a service called reviews, right? A Kubernetes service called reviews. So you basically have the namespace name and the service name are the same. So whenever you're going to send a request to reviews, default SVC, book info, whatever the namespace, right? The traffic will be load balanced across the pods in both clusters. It's not just going to be one, right? So if you say reviews dot book info, it's not just going to go to one cluster, right? It might load balance across multiple clusters. Yeah, and then traffic management rules provide fine-grained control over the behavior of multi-cluster traffic. So I think, yeah, so traffic management, yeah, and then you can use, yeah, we can take a look at this one, right? Yeah, follow the concept of the namespace sameness. Yeah, in some cases, cross cluster, you don't want to do that. You want to keep traffic cluster local, right? So cluster A can only reach services in cluster A. So you can do this like this by setting the cluster local to true and then setting the hosts, right? Partitioning with the subsets, so you can use the topology labels, right? And what else? Variable, you can do mirroring and shifting, right? Yeah, and then in your virtual service, you can try to match on where the traffic is coming from and then direct it to cluster one, right? So if the requests for my service, my namespace are coming from cluster one, you want to route the traffic to cluster one, to subset one, right? Which is whatever has this topology label set. Otherwise, you do cluster two. DNS with multiple clusters. When a client application, it must run DNS lookup. In Kubernetes, DNS services residing based on service definitions. So Istio uses virtual IP returned by DNS lookup to load balance across the list of active endpoints for the requested service, taking into account any routing rules. So Istio uses Kubernetes services or endpoints, or if you want to add a new service to the registry, you would create a service entry to map the host name to the actual IP. Yeah, this becomes complicated. So Kubernetes is not multi-cluster aware. So the client cluster must have a DNS entry for the service in order for a DNS lookup to succeed. So this is true even if there are no instances. Now, to ensure this, you must deploy a Kubernetes service to each cluster that consumes that service. So if you have cluster, reviews service in one cluster, and you want to access that review service from another cluster, you'll create a service there as well, right, in that second cluster. But there are some features that you can do this automated, and we'll take a look at this. All right, so the next dimension, I guess, is the network models. So Istio is simplified definition of network to refer to workload instances that have direct reachability. For example, by default, all workload instances in a single cluster are on the same network. So one pod within a cluster can access another pod in the same cluster through an IP address, right? This is just the same explanation here. What is a workload instance? So a single instantiation of workload's binary. A workload instance can expose one or more endpoints and can consume one or more services. Yeah, so this is basically a pod, right? Many production systems require multiple networks or subnets for the reasons of isolation and high availability. And Istio does support spanning the mesh over different network topologies, and then you can pick whatever fits your existing topology that you already have. All right, simplest case, you have a single network where all workload instances can reach other workload instance without using an Istio gateway or any intermediary, right? Yeah. So one thing to note is the endpoints cannot have the overlapping IP addresses. Kind of makes sense, right? Even in like single network across multiple clusters, right? Single mesh, single network. You can have different subnets, but the point is, in a single network, all workloads you can reach them by IP. Istio uses endpoints for routing traffic. How can Istio guarantee that the IPs don't overlap? I don't think Istio necessarily guarantees that. You would have to guarantee that, right? All right, so that was single network, so multiple networks. So a single mesh across multiple networks, and this is what is known as multi-network. So what are some of the benefits over the single networks? Overlapping IP or virtual IP ranges for service endpoints, crossing of administrative boundaries, fault tolerance, scaling of network addresses, and then any compliances or any standards that you have to comply with in terms of like if you require specific network segmentation. Now the difference here, so single network, IP to IP accessibility or reachability. Now in the different networks, the workloads can reach each other through one or more Istio gateways. So this is how it looks like. So you have a single mesh, but you do have gateways on both sides for both networks. And what this does is you're basically exposing your services or subset of those services through that gateway. So if service A on network 1 wants to talk to service B on network 2, it would have to call through the gateway, through the second gateway, to get to service B. It can't go IP to IP directly, right? Because it's a different network. Cloud vendors so cloud vendors may provide options that will not require exposing services on the public internet. So this is likely to be your best choice if you can do like an internal only load balancer, right? So it's not actually exposed to the public internet. To ensure secure communications, Istio only supports cross-network communication to workloads with an Istio proxy, which you're going to have the meshes there, right? So the way this is done, and we'll see this in the configuration, is one of the prerequisites that we started with, like this is where we started with, but we went here. We haven't gone to the requirements yet. But one of the prerequisites is that the both clusters share both meshes share both deployments, I guess, share the common root of trust. So service A can do a mutual TLS handshake with service B. And the way it does that through the gateway is that this gateway is configured with the pass-through mode. So the east-west gateway is not going to terminate TLS. It's going to let the connection go through, and then it's going to be terminated on the workload side here. So this workload is going to do a mutual TLS handshake with workload A, and the gateway is just going to be merely a door that it goes through. That's it. So that was network. Next one is the control plane models. So Istio Mesh uses control plane set of systems to configure. To configure all communication between workload instances within the mesh. Workload instances connect to the control plane to get their configuration. So think of it, I have my YAML that I want to apply, right? I have to apply it to Istio's control plane, right? And when I do that, that control plane translates the configuration to Envoy, and then pushes the configuration to the workloads, right? And this is an example of a single mesh, single cluster, single control plane in this one cluster model. This is how it looks like. And cluster like this, where one cluster has its own control plane, this is referred to as a primary cluster. So a primary cluster is the one that has the control plane. So in a single mesh, you can have multiple primary clusters, right? And these can then act as control planes for something that's called a remote cluster. So just reading this, primary cluster has a control plane, and I'm assuming remote cluster doesn't have a control plane and somehow magically connects to the primary cluster to get its configuration, right? And I think there might be there's definitely an image, of course, the next one here that shows how this looks like. So multi-cluster deployments can share the control plane instances. In this case, the control plane is in one or more. You can think of having more of these primary clusters. And then clusters that don't have their own control plane are referred to as remote clusters. This explains what it is. And then a remote cluster, the way it's configured, well, it has to be configured in such a way that it knows that these workloads, when you start them, know how to connect or where to connect to, right? Because they're not connecting to something running in this case, cluster east, right? They're connecting to a control plane running in a different cluster. Now, to support this, the control planes in primary clusters, so STOD, must be accessible via a stable IP address. And the way to do this, if you have multiple networks, is to expose a control plane through an Istio gateway. So this is very similar to, if I scroll up, to having like workloads on multiple clusters. Like when service A talks to service B, it has to go through this east-west gateway, right? A second scenario for this east-west gateway is connecting. So let's say service A connecting through the east-west gateway to a control plane running in another cluster, in another network, or on the same network, right? So cloud vendors may provide options, so internal LBs, right? Yeah, this is the repeat of what was said above. Yeah, so this is I think this is the same copy paste that's up there. But yeah, so you can do this through an internal load balancer. So if you have more than one primary cluster, so each primary cluster receives its configuration from the Kubernetes API server residing in the same cluster. So each primary cluster, therefore, has an independent source of configuration. So this duplication of configuration across primary cluster does require additional steps when rolling out changes. So you can automate this with CI/CD, right, to manage configuration rollout. Instead of running control planes so let's think about this one a little bit, right? So if you have more than one primary cluster, so primary cluster A will have its view of the world and the configuration that it knows about. And then the second primary cluster will have another independent source of configuration in their own cluster, right? So there are some steps that you have to do to roll out the changes into, like, the configuration changes across multiple primary clusters, right? So if you create a destination rule in cluster 1 that is a primary cluster, you'll have to do the same in cluster 2, because that one is assuming it's a primary one as well, right? So another option here, so instead of running control planes in primary clusters inside the mesh, a service mesh composed entirely of remote clusters can be controlled by an external control plane. So an external control plane is a control plane that externally manages mesh workloads running in their own clusters or other infrastructure. So the control plane could be deployed on a cluster, however, although not in one of the, yes. So the idea here is that you can cleanly separate, the control plane from your clusters, right? So this external cluster where your control plane is running is the actual, if you think about it, the primary, right? Primary control plane, or a cluster, if you will, where all the remote clusters connect to. Right? Yeah. So an example here is when you have any cloud vendor, right, that basically says, hey, we're going to manage the control plane for you, right? You don't have to do that. That's what the external control plane is, right? So in order to achieve high availability, you should deploy multiple control planes across zones, clusters, zones, or regions. So let's take a look at this one. Still a single mesh. We have west 1 and 2 and east 1 and 2. And then in the west section, in the west 1 cluster, we have a single control plane. And then we have another remote cluster. So we have one primary cluster in west region. And then we have one remote cluster in west that connects to the control plane in the west cluster. And then you have the same thing or similar thing on the east side. Single primary cluster with a control plane and another remote cluster in that same east region that connects to that control plane. And I think this doesn't tell us anything about networks, but we could assume that there's I mean the network is like, forget about the network in this case, but this could be, probably you will have one network for west and then one network for east. So between these, the communication here would probably go through east-west gateways, right? And the other thing that you would probably have to do is you would have to let's say service A from east 1 wants to reach let's say service C that's deployed in west, right? So if you deploy a service C in west, you will also have to create a service C here as well and duplicate the configuration because it's a separate control plane. All right. So what are some of the benefits? Improved availability. So if one control plane becomes unavailable, the scope of the outage is limited to the workloads in cluster managed by that control plane. So if this goes down, you still have east 1, right, that you can depend on. You can make configuration changes. That's another one. You can make configuration changes in one cluster, zone, or region. So you can make changes in this cluster only. You don't have to replicate changes there if you don't want to. If you want to test things out, right? That's how you would do that. So question. So we're starting our Istio and Kubernetes journey. I wanted to understand whether we can start with a single primary. Yes, you can. Yeah. You can start with a single primary cluster, and you'll see this in as I hopefully, what is the time? Let me check the time. So, 30 minutes already. Maybe I should start reading faster. Yeah, you can start with a single primary one. There are some things that you would probably have to set, like the mesh name and network name and whatnot, right? So you could theoretically set up your single Istio deployment, single cluster deployment, as if you're setting up a primary only multi-cluster, right? Just if you set it up that way, then you can always later connect to remote clusters, or actually connect remote clusters to there. All right, so endpoint discovery with multiple control planes. In order to make this work, each control plane must observe endpoints from the API. So the API servers need to have access to another API server, and there's a command in Istio-CTL that allows you to basically exchange the secrets, so one API server can connect to another one and then discover everything, so they can do the cross-cluster load balancing. Might not be desired. Yeah, this is where you can then control if you want to keep the traffic local to the cluster. When a workload instance is created, Istio assigns a workload an identity. Yes. So CA creates and assigns the certificates to verify the identity. You can verify the identity of the message sender with the public key of the CA that created and signed the certificate. And then a trust bundle is the set of all CA public keys used by the mesh. With mesh's trust bundle, anyone can verify the sender of any message coming from the mesh. So the CA signs. This model allows workload instances to authenticate. Yeah. So this is the ability to. Well, this is just single cluster, right? You have a CA, and then control plane uses this CA to issue the certificates to individual workloads. Now, how do you do this across clusters? You have to exchange these trust bundles. Yeah. So you can use I think I want to say last episode that we showed how to do the spiffy trust domain federation, right? So you can have one trust domain, another trust domain, and then federate them together, which basically allows the services from across multiple cluster in the same mesh to talk to each other. And a single mesh, multi-mesh, tenancy models, cluster tenancy, mesh tenancy. All right. So for the sake of time, I'll skip this last part. Not that it's not important, but maybe it's not for this first thing that we want to do. So yeah, 37 minutes in, I can understand if people are like, "Oh my God, this is complex," right? Because just reading the deployment model here, it's like, "Oh, okay, there's a lot of stuff that I have to know in order to, well, not to know, but actually to understand if you're setting this up, like for production use, of course." All right, so let's go back to the first page. We're still here. So I did before you begin. So this is the second one. We went through the deployment models guide, and now we're going to see what are the requirements, right? So 2 clusters, supported versions. So that's one requirement. Having a cluster with two or more clusters with the supported Kubernetes version. The second one is the API server access, where each cluster must be accessible to the other clusters in the mesh. So you can do this with the network load balancer. Yeah, so this is where the east-west gateway is used to enable the API server access. Environment variables. So the guide is using like 2 environment variables, cluster 1 and cluster 2. This is just the context. So set this up. So let's do let's see. So let's do kind create cluster, and we'll say cluster 1. I'll create 2 clusters locally. I hope I have enough. I know I have another cluster running, but so while that's doing, so multi-cluster. So we have to establish trust between all the clusters in the mesh. So there's multiple options. See certificate management. Plugin. Yeah, okay, so this is how you just provide the CAs. Depending on which, the installation might change slightly. So if you're planning to deploy only one primary cluster, you will only have a single CA, because primary is the one that has the CA, right? Remotes are connecting to the primary and then getting certificates issued from that primary. In that case, you can skip the following CA step generation, CA certificate step, and simply use the default. Yes, yeah. So the thing here is just a note: when you install Istio by default, your Istio will use a self-signed CA, right, for all the certificates. And what this is saying is, if you're just doing primary remote, for the purposes of going through this walkthrough for production, you should have like a proper CA and do not use a self-signed one, right? So this guide assumes that you use a common root to generate intermediate certificates for each primary cluster. Yes. So the idea here is, let me open the docs here. So you create your root CA, and then you create an intermediate CAs for every primary cluster that you have, right? So since we're going to do hopefully one primary, one remote, we could just go with the default self-signed CA, but ideally you would create a root CA, and then from that root CA you would create an intermediate CA for your primary cluster, and that one will be used for your remote clusters as well. So the idea with intermediaries here is that you could go to a root CA and create a new intermediate CA, and then replace it in case you want to rotate those as well. Okay, so if you currently have a single cluster, you need to change the CA. Changing the CA that requires reinstalling. Yeah, so this is going back to the question. That's what I said. Try to follow the primary cluster setup in the multi-cluster section. That way you're going to be ready for the multi-cluster. All right, so it's saying that we're now ready to install Istio across multiple clusters. So let's go back. Okay, covers. All right, so this is what we went through already. Now, for someone like if you're watching and this is new to you, what is something, and if you've watched what I went through, what would be something that's missing here that you would expect to see here that you would need to know right away that was maybe uh, buried somewhere here in the documentation? Let me know in the comments if you come up with something. All right, so here are the different combinations, I guess. So multi-primary, where we have multiple control planes. Primary remote, where you have one primary and then one or more remote clusters that connect to it. Multi-primary, so this is the same as this first one, but it's on different networks. And then a primary remote, same as this one, but running it on different networks. So let me do, so since we're going to do primary remote, so what I want to do is let's quickly compare and actually see what is the difference between primary remote on the same network versus primary remote on a different network. And I don't think there's, let's see if we can spot the differences, right? So it's the same thing here. We're doing one primary, one remote, and the remote one will use the control plane in cluster one. And both clusters will be on network one because they have one network. They're running on one network, and there's the direct connectivity between the pods. On the other side, on the right hand side, primary remote, same thing, but we have network one for cluster one and network two for cluster two. So there's no direct connectivity between the pods. And let's see what that means. Before proceeding, there you go. So if you're testing multi-cluster setup on Kind, you can use Metal LB, and I have that. So let me just, so I have cluster one. I just do cluster one, and I'll install Metal LB on cluster one. And then I'll set that up as a primary, and then we can go and set up a remote one. Let me make this a little bit bigger. There we go. All right. So you can use Kind, and if this is your first time setting anything up, go with Kind. Might be easier, right? All right. So one note here on the primary remote on the same network. The instructions are not suitable for AWS primary cluster deployment. The reason is that AWS LBs are presented as fully qualified domain names, while the remote cluster utilizes the Kubernetes service type external name. However, the external name type exclusively supports IP address and does not accommodate fully qualified domain names. If, by the way, if anyone wants to do their first Istio documentation contribution and fix, this external name, look at these backticks here. For some reason, it's not rendering it as these, right? So there's probably something wrong there. So if anyone wants to go and fix this, it's a nice first contribution. All right, so in this configuration, I'm trying to line it up. Actually, let's line it up like this. So cluster one observes the API servers in both clusters for endpoints. So cluster one, so this one. So STOD will have access to API server in its own cluster, as well as API server in the remote cluster. Right? So in this way, the control plane will be able to provide service discovery for workloads in both clusters. Yeah, so if you bring up service B or service C here, STOD will create an entry for it in its internal registry. Right? The workloads communicate pod to pod because there's pod to pod. It's the same network, right? So they can talk like that. So let's look at the multi-network one. So the same thing. And then the workloads cross-cluster by communicate indirectly. So there's a requirement. Notice there's a gateway here as well. So there's the difference, right? There's a gateway on the cluster 2 side. And this is what's used to for the workloads to communicate. So the gateway in each cluster must be reachable from the other cluster. So from here, I should be able to reach gateway in cluster 2, and then from here, from service B, cluster 2, network 2, I should be able to reach gateway in cluster 1, network 1. So this is either probably not a publicly accessible IP address to the internet, but it's like an internal IP address that's accessible within like your VPC there. So services in cluster 2, yeah. So services in cluster 2 will connect to Istio using the same east-west gateway, right? Over here, they can connect directly, right? Over there, they have to use the east-west. Actually, this looks like service B is going through the gateway here as well. So I think the connecting to Istio, and maybe this has to be, maybe it's clarified somewhere later on. For workloads to connect to Istio, they will always go through the east-west gateway, regardless if they're on one network or two networks. And we'll confirm that shortly. In the multi-network example, service B talking to service A will also go through the east-west gateway, while as where you have a single network, it will just go directly. So configuration always goes through the east-west gateway, but then in the multi-network setup, pod to pods also talk through the east-west gateway. So configure cluster 1 as a primary. And then what is this one doing? So this one is setting the default network for cluster 1. So if Istio namespace is already created, we need to set the cluster's network there. So this is creating the namespace and then setting the topology Istio.io network to network 1, right? So that's an extra step that we don't do when we have a single network. So let me go to here. So I have metal LB, right? Let me make this a little bit bigger. I don't have anything installed. So what I have to do is it's saying create this cluster 1 Istio operator. So what we're doing here is we're setting the mesh ID, we're setting the cluster name to cluster 1, and we're setting the network name to network 1. So let's take this. And I'll just do a temp folder here. Oh, I already had a temp folder. Temp 1. Nope. Temp 1. Oh, wait. Too many temp folders. Temp 1. All right. So let's do this. Yep. So we have cluster 1. Yep. And then we can apply the configuration to cluster 1. So we're using Istio install. We're setting the pilot external Istio to true. And then, well, setting the context, I don't have to set the context yet because I only have one cluster 1, right? And then deploying this Istio operator. So what is the external Istio is set to true? So this enables the control plane installed in cluster 1 to also serve as an external control plane for other remote clusters. When this feature is enabled, Istio will attempt to acquire the leadership lock and consequently manage appropriately annotated remote clusters that will be attached to it. And yes, and this takes us to a different portion. I'm not going to click it so I don't lose the flow, but this one will have to like mark and annotate the remote cluster that's attached to this one. All right, so let's do, let me see, what version do I have? 121.0, so we'll do set values, pilot. Let's see, pilot, I can type. It can be external Istio D equals true. I'm not going to set the context because I'm pointing to cluster one already. Cluster1.yaml. What? Oh, it's version. Ugh. Install. So this will install the default profile. It's going to install Istio core, Istio D, and Ingress gateways. Proceed. Yes. And then on this side, let's take a look. On the multi-cluster side, or multi-network, different network side, it's the same thing. Like notice the installation of the primary cluster is exactly the same, right? It's mesh one, name of the cluster, name of the network, same command, right? Installing it the same way, right? So the only difference up until now was we also labeled, right, our cluster one with network one with this topology label. So the step two is, and this confirms my suspicion that, so east-west gateway is always used for workloads to connect to the primary cluster's control plane, right? So it's always used for that, right? So install a gateway in cluster one that will be the dedicated east-west, dedicated to east-west traffic. So this gateway will be public on the internet. Production systems might require, yep. So you have to protect this, right? Check with your cloud vendor. You could do like an internal or private IP or something like that, right? So it's not publicly exposed. That's what I mean, right? So in this example, we'll use the Gen East-West Gateway script and we'll pass this in. So we're basically using that script, passing in mesh name, cluster name, network name, and then taking the output and then using istio-ctl install to apply it to the cluster. So what I'll do is, actually, let me open another. How can I split? Oh, I don't know what I clicked, but how do I split it? I'll just do it this way. I'll open another terminal here and I will go to my Istio 1, what was it, 21? 0 installation, because that's where that script is in the samples multi-cluster Gen East-West Gateway script. So let's just create that. So let's just samples multi-cluster Gen East-West Gateway, and we'll say mesh equals mesh 1. Cluster is cluster 1, and network will be network 1. So let's see what we get. All right. So it just spits out the YAML, right? So we got another Istio operator called east-west. It's using a profile empty, so it's not going to install any STOD. It's not going to do any of that. By the way, we already have in the cluster, we have an Ingress gateway running. We have STOD running. And just to double check, I do have over here, I do have an external IP address for my Istio Ingress gateway. Right, so we have that already installed. So what we're doing next is we're installing an Istio East-West gateway, setting the labels, setting the topology. Notice network 1. I'm assuming like this comes into play to know who connects to what and which East-West gateway to use to connect to the control plane. We're setting that it's enabled, right? Setting an environment variable called Istio meta requested network view. So traffic through this network should be routed inside the network. So value 1. Yeah, so anything that goes through this east-west gateway will be routed inside this network. This is just the normal like services for the I think for the gateway, and it's saying use this injection template for a gateway, and then setting the network to network 1, right? So the only thing that this is doing is basically installing an Ingress gateway with this topology label set and with this environment variable set, right? So let's do that. So I'll use the same command, and then we'll do istio-ctl install f like this, right? And this is just going to install the east-west gateway. That was fast. So if I look at the pods, you'll notice we have the ingress gateway from the initial installation of the control plane, and we have this east-west gateway. And then if we look at the services as well, you'll notice that I have 172.18.255.201 external IP address for this east-west gateway. Right? So far, more or less the same instructions. So the next one is expose the control plane in cluster 1. This is exactly the same as well. And it's saying before we can install on cluster 2, we can install what? We can install Istio. There's our second contribution for someone if they want to fix the documentation. We need to first expose the control plane in cluster 1 so that services in cluster 2 will be able to access service discovery. So what this is saying, once we set up cluster 2, any workloads that we start on cluster 2, those workloads will have to connect to Istio-D in order to receive configuration. And this one is telling us, apply this expose Istio-D YAML to cluster 1. And this will expose the services, it's going to expose the control plane in cluster 1, right? So let's see how that looks like. And that's going to be here. So I'm samples, multi-cluster, expose istio-d.yaml. So let's take a look. All right, so what do we have here? So we have a gateway resource, and we have a virtual service. Right? So the gateway resource is configuring this east-west gateway that we installed. It's setting it's specifying the port protocol to TLS. It's setting the mode to pass through, meaning don't terminate the connection, just pass it through for any hosts, right? And then same for 15.0.17, set it to pass through, and this is the Istio-D webhook, right? So this is the connection to Istio-D, and this is the connection to Istio-D webhook that's exposed through the east-west gateway. Then the virtual service, what it's doing is configured for all the hosts. It attaches to that Istio-D gateway. So what that means is that it exposes the services, whatever we define here, right, through that gateway. And it's doing a TLS match on the port, this one, 15.0.12, for all host names. And it's just saying, well, anything coming in that matches this port, right, on Istio-D, route that to Istio-D, route that to control plane, pretty much, on this port. And then same thing for port 15.0.17, route that as well, but to port 443, right? So that's what this exposing the Istio-D is doing, right? It's just configuring the east-west gateway for allowing the workloads in a remote cluster to connect through that east-west gateway and reach Istio-D in that primary cluster. So let's apply this. So we'll do apply, deploy to Istio system and samples, multi-cluster, expose istio-d.yaml. There you go. So 2 of these are configured. And then if we take a look at the gateway Istio system. Oh, sorry, actually VS, right? Oops, not CS, VS. VS. We have Istio-D, VS attaching this gateway for all the hosts. Right? So this is the same. So next one is set the control plane for cluster 2. So we need to identify the external control plane cluster that should manage cluster 2 by annotating the Istio system namespace. So note that this is cluster 2 now. So we need to create the second cluster. So let me quickly do that. Create. So let's do cluster 2. and then we can continue. So we have three. So let's say you have three AWS accounts, dev, queue, prod, each with 5 clusters. Each cluster would have its own VPC and have 700 node. That's a and have 700 nodes, each hosting 1,200 in each account. Which topology would you use? Well, that's an interesting. I would have to think about it. It's hard to say. Like, get a question on, like, how is, like, are you doing Tennessee based on your like accounts, or is like QA talking to dev and dev talking to QA as well? How, like, I would definitely keep the dev and QA separate, right? That kind of makes sense, right? Each cluster would have. I mean, the fact that you have 3 accounts, you would set it up the same for each account, right? And then replicate the same thing, and then each cluster would have its own VPC, and so you already have multi network, right? Combine, yeah. Interesting. I mean, I would boil it down to just one account, figure it out how it works there, uh, and then replicate the same thing for other accounts, right? If you want to have 3 different, I'm assuming the 3 different accounts don't. You don't. Do you need a connection between dev and prod or QA and prod, right? I guess that would, you would have to configure that, but you would definitely need yeah. It's, you're gonna have a complex time setting this up like manually, right? As you see, like, what we're going through this here, it's not going to be uh, as straightforward, right? All right, let's see if we've set up the, yes. So we have cluster 2. So what are we doing now? Let me just make sure to switch to cluster 2. We're going to create the namespace called Istio system. And then we're going to annotate the namespace saying control plane clusters, cluster 1. So basically saying cluster 2 is managed by cluster 1. So the control plane for this cluster is cluster 1. Right, so let's apply this. So we'll do annotate namespace Istio system topology Istio control plane clusters equals cluster 1. There you go. And this is all in cluster 2 now. So setting the topology namespace annotation to cluster 1 instructs the STOD running in the same namespace, Istio system, on cluster 1 to manage cluster 2 when it's attached as a remote cluster. So setting the topology namespace to cluster 1 instructs STOD. Yeah, so that will tell, once we connect the remote cluster to cluster 1, that label from the remote cluster, this one, will basically tell STOD, hey, this is a remote cluster that you need to manage as well. Right? Okay. And then the extra step on the right-hand side here, this is for the multi-network setup, is to label the cluster 2 with the network label. So notice in the same network, we didn't label the namespaces. We didn't label the namespaces with the network name, right? Because it's all the same network. The second thing, the next, is let's configure cluster 2 as remote. So first off, save the address of cluster 1's east-west gateway. So let's do kubectx, and I'll switch to cluster 1, and I'll get the service of, so we'll get the east-west gateway, right? And we'll store this into discovery address. There we go. So this is my east-west gateway on cluster 1. We have that. And then let's switch to cluster 2. So there's, like, going through these, if you're going through these the first time, I would suggest you actually set these context variables, because you can very quickly like forget to switch the context, and then deploy something in a cluster that you should not be deploying it there. And then we're creating, and I'll actually create it here. So I have it in the same place. Oh, wait, I'll have to create it here. So we're creating an Istio operator resource using the remote profile this time. We're setting the Istio remote value, the injection path, to inject cluster, name of the cluster, network, and name of the network 1. And then setting the remote pilot, so pilot control plane, right, to the east-west gateway, right? So we're saying, hey, this is the address, this is the IP address where you can get to the control plane. And this is saying, here's configuring the location of a control plane using the injection path and remote pilot address parameters. Although convenient for demonstration in a production environment, it is recommended to instead configure the injection URL parameter using properly signed DNS certs, similar to the configuration shown in the. All right, so I would let's see how much more complex is that. Maybe that should be actually shown here, right? Or if there's a documentation page that specifically shows you how one would set this up for production, right? Because sometimes doing like this is fine for testing, but then for production, if things look different, and there's no documentation or no examples how to do that. Oh, okay, so it's like this. Okay, so it's not that different, right? So it's Istio, external Istio D. Oh, okay, so it's setting the namespace and then using the injection URL instead. So doing HTTPS address, okay, and then the full path like this, right? Paste file, modify the configuration. Yeah, now you can change the. It's interesting. Maybe the external one is more of a production ready one, since it's, I mean, not production ready, since this one is referencing that one for production. But anyway, yeah. Oh, okay. So it's using the DNS, like the actual DNS name and certs, but we're using the IP address here, right? Makes sense. Okay, so let's create this. So create cluster 2. Cluster 2, just make sure that it's there. The address was populated here, the IP address. And then let me double check I'm on cluster 2. I am. We'll do istioctl install cluster 2. So now we're installing the remote cluster. Yep. There you go. This was very fast. So Istio was the only thing installed. There's no ingress gateway in the remote cluster, right? And it's exactly the same here. So the next step is attaching cluster 2 as a remote cluster of cluster 1. So the way to do this attachment is to give control plane in cluster 1 access to the API server in cluster 2. So this will do the following. So it will enable the control plane to authenticate connection requests from workloads running in cluster 2. Without that access, the control plane will reject the request, and it's going to enable the discovery of service endpoints that are running in cluster 2. Because it has been included in the topology, in that annotation, the control plane in cluster 1 will also patch certs in the webhooks in cluster 2, and then start the namespace controller, which writes the, okay, I don't really get what this one will do. Start the namespace controller, which writes config maps in namespaces in cluster 2. So we'll write the configuration in cluster 2, maybe. We'll take a look. Let's see. So let's see. I am in cluster 2, right? Yes. So get config map, Istio system. So I only have the root CA. So what we'll do is, so first of all, we create a remote secret. So we use istioctl, and I am on cluster 2. So istioctl create remote secret, name cluster 2. So this is the secret, right? So this is what it does. So it creates a secret. So let's store this in a, I'll just call it cluster2 secret.yaml. There you go. It's likely not reachable from inside the cluster if you're using Kubernetes. Pass -s service with the container IP of the API server. Oh, so let's do that. So let's do container IP of the, do it like this. It should be, well, let's see. Let's have, we stored it, and then we can apply this. So let's do cluster1, apply cluster2 secret YAML. All right, so we have cluster2 secret created in cluster1. And now we're already being congratulated that we've installed Istio Mesh across primary and remote clusters. And now we can go and verify the installation. So let's make sure. Oh, let's go back here and see what else is on the multi-cluster one. Okay, so on the multi-network setup, so we give access, right? We create the remote secret from cluster 2, apply it to cluster 1, and then what we additionally do, we do the same thing we did in cluster 1. We install the east-west gateway with the network name and the cluster name, and then we expose services in cluster 1 and cluster 2. So this is a different YAML, different configuration that we apply. So let's take a look at that one. Multi-cluster, expose services. So what this is doing, since the clusters are on separate networks, we also need to expose all user services on the east-west gateway in both clusters. While these gateways are public on the internet, services can only be accessed by mutual TLS. Yes. So what this is additionally doing is configuring, setting this to auto pass through. I think this means, let's see exactly what this means. So I'm not making stuff up. Auto pass through. So similar to pass through, except servers with this TLS mode do not require an associated virtual service. Yeah. So previously, when we were exposing STOD, right, we had to have a virtual service, but this one does not. If you use auto pass through, it does not require us to create a virtual service. Because the destination details are in the SNI value, we're going to specify the service typically used between the, yes. Yeah, so the server is typically used to provide connectivity between services in disparate L3 networks that don't have direct connectivity, right? Yeah, and both sides have to use Istio mutual TLS to secure the traffic. So that was the, wait, let me see. Oh, I have way too many windows. Yeah, so that was the last thing on the multi-network one. So it's not that different, really, right? You're just doing a couple of additional things due to the fact the way this works, right? There's nothing special there. So let's see if we can verify that it actually works. Hopefully, it'll work because it is unkind. So we create a namespace, called sample in both clusters. So cluster 1, create namespace sample, and then cluster 2, create namespace sample. So we have sample in both namespaces, in both clusters. Enable automatic sidecar injection, same thing again. So label ns sample istio injection equals enabled. Okay. And then if I switch to cluster 1 and do the same, okay. And then we're deploying hello world into both clusters. So we do apply samples hello world dot YAML service equals hello world sample, right? Okay, so this was cluster 1. Let's do the same in cluster 2. Okay. And then, so I didn't check that it's actually there, but well, what? So created the service. Oh, this just created a service. Yeah. So this created no, but it should create a deployment. No, I think this is just saying create a service, right? Yeah. So this is only creating the service. So we created a service in both clusters. And then we'll deploy V1 to create a V1 deployment in cluster 1. Apply samples hello world, samples hello world, and then version, right? Version equals V1 and sample. Okay, and now if I look at this, yeah, so it's initializing. Let's wait for this to come up. There you go. So we have hello V1 running, and then let's do the V2 in cluster 2. Apply version V2. Let's wait for this sample. Let's wait for this. What? Samples, what am I missing? Apply samples, hello world, label version equals V2 and sample. And it's saying it created it, but where? It didn't. Oh, I wonder if it's... oh, I probably don't have enough memory, I would guess. So let's take a look. Let me actually delete one of the clusters I have. Clusters list. Delete clusters, and I'm doing this off screen, but it's kind dash kind. Okay, so I should have more memory now, so this should come up hopefully. Scale deploy hello world v2 and sample replicas equals 0, and then scale it up. Why isn't this coming up? Oh, see, it's not. It's trying to connect, but it's not connecting. And I think this has to do with the fact that warning that we got earlier. Where was it? When we were creating the secret, right? Yeah. Well, that's what you get for using kind, I guess. Let me actually see what the error is. So I'll try to figure it out. So already hour and 20. Remote secret. There it is. So let's do kubectx cluster 2 and stctl create remote secret. This one was giving me a warning, right? Yeah, so this one is saying server in kubeconfigs https. This is likely not reachable from inside the cluster. If you're using Kubernetes and Docker, pass -- server with the container IP for the API server. So do I do this, the IP of this one? Is that what it's saying? API server, this one. So I would do, whoops. Oh, it froze. Oh, there it is. It's coming back. So I would do, what was the command? This one, -s server, like this. Oh, look at that. Maybe this will work. Oh, it's actually, yeah. so that it replaces the name, the IP. So let's do secret.yaml. And then we apply this to cluster 1. Secret.yaml. Okay, so this is configured. And then if we go to verify the installation, we're failing with deploying stuff. Right, sample. Oh, there you go. Yeah, I think that's what it was, right? I mean, oh no, it was in cluster 2, right? Sample. Yes. Okay. So let's delete, deploy. What is it called? Hello world v2 sample. Yep. And then, oh, this is what it was failing, right? So apply samples, hello world, version v2. Okay. Deploy. Let's see if this is the. No, I think so. Yeah, I think it's the issue of like it can't access it on kind for some reason. Oh well, we got far enough, and I think that if this was proper clusters, this will work. I will try to figure this out. What the actual like? How could I specify the IP that's like accessible from one cluster, right? Accessible to access the other one, but. All right. Well, I hope this was at least a little bit useful to people. Please reach out to me, Nipun. I know you had that question. Reach out to me on LinkedIn or Twitter or somewhere, and we can continue the conversation around that. Uh, but yeah, let me know if this was useful. I'll try to figure this out why it didn't work on Kind and get it to work. But I hope at least I hope I was able to at least clarify some of the multi-cluster things in Istio, and that there's not like specifically like what's the difference between primary and remote, right? How does that work? Secondly, what is the uh, single network versus multiple networks? What does that mean? And then what are the implications if you pick one or the other in terms of what do I have to set up? How do I have to configure things? And as you've seen, it's not that different if you do primary, let's say primary remote within a single network. It is simpler to set up versus in multiple networks, which is a little bit more work, but it's basically you're doing the exact same thing that you already did in cluster 1 anyway, right? When you have the single network. So the other, let me just go quickly look at through the multi-primary was the other thing that's kind of different, and then the network is just the differentiating thing, like single network or multiple networks. And the instructions here are basically, since you're setting up two primaries, you're basically repeating the same, using the same Istio operator anyway, as if you were setting up a single primary. You will have to create a remote secret and exchange those secrets between both primary clusters, and that's it. Right? That one is actually even simpler, right? On a single network, right? If it's on a different network, it's whatever you've already seen on in the primary remote, right? Whereas you would have to configure the east-west gateways, right? That's all there is. All right. Well, thanks everyone, and please do reach out. Like if you have any questions or if you have anything, like any ideas or anything that I should cover next, or even if you have anything you want to talk about, right? If you've done this before or something similar, and you think it would be worth your time to talk about it and present it, let me know. I would love to do that as well. All right, everyone. Thank you very much, and I'll see you next time.